Hello everyone. In this question, it is given that if the roots of the equation px square plus qx plus r equal to 0, where 2p, q and 2r are in GP, are of the form alpha square and 4 alpha minus 4, then we have to find the value of 2p plus 4q plus 7r. Okay, so it is given that the quadratic equation px square plus qx plus r equal to 0, this has roots alpha square and 4 alpha minus 4. Okay, and it is also given that 2p, q and 2r are in GP. Okay, so if these are in GP, then the square of the middle term will be equal to the product of the extreme terms, right? So from here it can be concluded that this is q square is equal to 2p times 2r, which means q square is equal to 4pr. Okay, now if the quadratic equation is px square plus qx plus r, right? So the discriminant of this quadratic equation will be equal to coefficient of x, that is q square, minus 4 times the coefficient of x square p and the constant term r, right? So this is q square minus 4pr. But we have derived, since these are in GP, 2pq and 2r are in GP, q square is equal to 4pr, right? So this implies that q square minus 4pr will be equal to 0. So this now implies that roots of the equation, the quadratic equation that is given, px square plus qx plus r equal to 0 are equal, right? Since the discriminant is equal to 0, this is the conclusion, right? So this implies that alpha square will be equal to the other root 4 alpha minus 4, right? So on changing the sides, this becomes alpha square minus 4 alpha plus 4 equal to 0. So this can be factorized into alpha minus 2 times alpha minus 2 equal to 0, right? Since this is alpha minus 2 whole square, I am writing these as two separate linear factors. Okay, so since the roots are equal, from either case you will get alpha equal to 2. Okay, now the roots are alpha square and 4 alpha minus 4. So the roots of px square plus qx plus r equal to 0 will be alpha square, that is 2 square, or 4 alpha minus 4, right? So this implies the roots are going to be 4, and this is 8 minus 4, that is 4 again. So the roots of this equation are 4 and 4. So this implies that px square plus qx plus r equal to 0 will be equivalent to this, right? This is from the factor theorem. Using factor theorem, if a is a root of a polynomial, then x minus a will be the factor, right? So this is the factor theorem. So from here we can conclude that this px square plus qx plus r equal to 0, it will be the same as x square, and this will be 8x plus 16. Okay, so on comparing both sides, we get p equal to 1, q equal to minus 8, and r equal to 16. Okay, so we can check the value 2p will be equal to 2, right? And q is equal to minus 8, and 2r will be equal to 32. So we can check that q upon 2p is minus 8 upon 2, which is minus 4, and 2r upon q, which will be 32 divided by minus 8, which is again 4, minus 4. Okay, so our condition that 2p, q, 2r are in GP is satisfied for these three values, right? GP is satisfied. Okay, this is the extra part. This is not needed in the question. We were required to find this value of this expression. Therefore, 2p plus 4q plus 7r, 4q plus 7r, this will be equal to 2 times 1 plus 4 times minus 8 plus 7 times 16. So this becomes 2 minus 32, and 7 times 16 is 112. Okay, so this 2 minus 32 will be minus 30. 112 minus 30 is 82. So this is the required final answer. Okay, so this is the final answer. This was a relatively easy question. All things considered, this is a very um, considerably easy question. Okay, so this is it. If you have any doubt, this you shouldn't have any doubt. This is relatively very easy to understand, right? So this is the final answer. Okay, thank you.